Hi, welcome. Today we'll be going over number 2 on the 2014 AP Calculus BC FRQ section. This is the question that we'll be going over today. But before we go into the specifics of this question, I'll be showing you how to use your calculator because there are some functions you need to know to solve this question. Now here is a TI-84 plus graphing calculator. Many of you have probably seen this calculator. Obviously you can use any other graphing calculator to these functions, but I'll be using this calculator. So this math button right here, you want to press to begin our derivation or integration, and that should give you this table. And obviously you can see number 8 and 9 are derivative and integral functions. So we'll start with derivative function number 8. You highlight this on your calculator, click enter. That should give you this line. And our first box right here is where you put your variable. In the middle you put your equation, and in the last box with the line you want to put the value at which you want to take the variable at. Now up next we have the integral function number 9. Highlight this, click enter on your calculator. That should get you this line right here. Now on these first two boxes right here, you would want to put the bounds in which you are integrating. In the middle, like in the derivative, you would want to put your equation, and at the end you would want to put your differentials, or like your variable, so dx or d theta. That concludes all you need to know for this question on the calculator. Let's get to the actual FRQ. Let R be the shaded region that is inside the graph of R equals 3 and inside the graph of R equals 3 minus 2 sine 2 theta. Find the area of R. Now looking at this, you see that the semicircle or the quarter circle in the second quadrant and the first quadrant area is what makes up this region R. So we can use our circle equation for the second quadrant, a equals pi r squared, to get the area. Not too hard. But on this one, on this weird area, we see that it's the area bounded in the first quadrant by r 3 minus 2 sine 2 theta. But to find the endpoints, we set r equal to each other to find our theta, in which we should integrate the function. So this gives us 3 equals 3 minus 2 sine 2 theta, and since sine goes to 0, when at 0 or pi, we get theta equals 0 or pi over 2. So the area of this first quadrant region, we use the polar area formula, 1/2 integral r squared with our bounds, and we put in r, so a equals 1/2 integral 0 pi over 2 of 3 minus 2 sine 2 theta squared d theta, and then we will add the two areas we found to find our total area. So we get this equation, and plugging that into our calculator like I showed you before, we get 9.708 as our final answer. Now for part B, for the curve r equals 3 2 sine 2 theta, find the value of dx d theta at theta equals pi over 6. Now looking at this question, it asks for dx d theta, so we need to find an equation that describes x. So we use x equals r cosine theta, and we know our r, so we just put our r into this to find the equation for x, which gives us x equals 3 minus 2 sine 2 theta times cosine theta, and find the value of dx d theta. So all we do is take the derivative of that when theta equals pi over 6. We put that into our calculator like I showed you before, and at theta equals pi over 6 we find that dx d theta equals negative 2.366. Now part C, the distance between the two curves changes for 0 less than theta less than pi over 2. Find the rate at which the distance between the two curves is changing with respect to theta when theta equals pi over 3. Now the distance is between the curves are changing, and the distance can be shown right here. And the equation for distance is just subtracting the two curves. So 3 minus, in parentheses, 3 minus 2 sine 2 theta, which just gives us 2 sine 2 theta. And the rate at which the distance is changing can be found by the derivative. So we just take the derivative of 2 sine 2 theta, and theta equals pi over 3. Plug that into our calculator, like always, and we get d over d theta equals -2. Now moving on to the last part of the FRQ, a particle is moving along the curve r equals 3 2 sine 2 theta, so that d theta over dt equals 3 for all times t greater than or equal to 0. Find the value of dr dt at theta equals pi over 6. Now, let's start with what they give us first. They give us that d theta over dt equals 3. And you know that dr d theta is dr dt over d theta dt. Simple algebra. If you divide the top, bottom by dt, it should equal the same thing. Now, so you can see that to find dr dt, you just multiply each side by d theta over dt. And since we have d theta over dt equals 3, you can plug that into your function or equation, and you get dr over dt equals 3 times dr d theta. Now, dr d theta is just derivative of our r, so we have 3 d theta in parentheses 3 minus 2 sine 2 theta when theta equals pi over 6. We plug that into our calculator yet again, and get 3 times -2, which is -6, which is our final answer. Now, thank you for watching. I hope this was helpful, and there are resources further available in the description below. Good luck.